Hello, in this lecture the chapter that we will be learning is Binary Data Representation Part 2, which has decimal binary conversion, octal decimal conversion, octal binary conversion, hexadecimal decimal conversion, hexadecimal binary conversion and hexadecimal octal conversion. We will learn all these conversions by a practical session. The first one is decimal to binary conversion, in which we will convert a decimal number to a binary number. For that we have a decimal number that is 455 base as 10 and we will convert it into a binary number which will have 2 as a base. Now we will write this 455 in a specific format. Now 455. We have to divide this 455 by 2. Obviously 455 is not perfectly divisible by 2. So we would write the quotient part over here, that would be 227. The remainder would be 1, that would be written here. Now again divide 227 by 2. The quotient would be 113 and remainder would be 1. Again divided by 2. We would have 56 as quotient and 1 as remainder. Again, here 56 is perfectly divisible by 2, so we would have 28 as quotient and no remainder, so we would write 0. Again, 28 is perfectly divisible, so we would write 14 with 0 as remainder. Again, 14 is perfectly divisible, so we would write 7 with 0 as remainder. Now 7, we will get 3 as quotient and 1 as remainder. 3 is divisible by 2 and we would get 1 as remainder. Now here the 1 is less than 2, so obviously we can't divide this 1 by 2, so that's why we would write this 1 directly here. And this is our answer. All these remainders is our answer. We would write these remainders from bottom to top. That would be 1, 1, 1, 0, 0, 0 and 1, 1, 1 base as 2. So this is our answer. Again I am repeating, we have to write from bottom to top. Right? We will highlight some basic functions of this conversion. Here 2 into 227 would give us 454 and 1 is remainder that we have written here. Now again this 113 into 2 would give us 226 and the remainder is 1 that is written here. Now again this 56 into 2 would give us 112 and the remainder is here. And this 2 into 28 would give us 56 with no remainder, that's why we have written this 0 here. So this whole conversion is nothing but just a simple division problem. The format of writing it down is a bit different, that's all. Now the next is the binary to decimal conversion that we have already learned before. The second one is binary to decimal. For that we will convert this binary number that we have got from this decimal number into a decimal number. So in one way we will convert this binary into decimal, and in other way we will check that if the answer that we have got from this problem is right or not. So for that we would write it. This number is a bit further away, like we have done earlier. 1, 1, 1. This would give us 2 raised to 0. This would be 2 raised to 1. This would be 2 raised to 2. you have to multiply all this with 1, remember? But now that you have practiced a lot, it will be fine if you don't write, but you just have to remember this. Again, for all this, it will be 0. For this one, 1 into 2 raised to 6. For this, it would be 1 into 2 raised to 7. And for this, it would be 2 raised to 8 into 1. So, now the answer, we have to add all this. So, it would be 1 plus 2 plus 4 plus 0 for all this 3 plus 2 raised to 6 would give us 64 into 1. So, that is 64 plus 2 raised to 7 would give us 128 into 1. Obviously, 128 raised to 8 would give us 256. Now, we have to add all this, and the answer that we would get is 455. You must use your calculator for this kind of problems. So here we got 455 again. So our answer was perfectly fine and correct in this previous calculation, and again we have converted this binary into a decimal number. So that is here. Now, the next conversion that we would be learning is a decimal to octal conversion. That is, we will convert decimal number into an octal number. In octal number, the base is 8. The decimal number that we have got here is 397. Base is 10, and we have to convert it into an 8 base number, that is octal number. Now again we will write that in that format. That is 397. But the only small difference that would be here is we would divide it by 8, because we have to get an octal number for which base is 8. So we would get 49 as quotient and 5 as the remainder. Again, 49 divided by 8. The quotient would be 6 and the remainder would be 1. Now, 6 is less than 8, so we can't divide it. So we would write 6 directly here. Now our answer, that would be bottom to top. So our answer would be 615 base as 8. So now the next conversion that we would be learning is octal to decimal conversion. Octal to decimal. For that, in the previous conversion we have got 615 is an octal number. Now we will convert it into a decimal number. So we will check if we are getting 397 as a decimal number or not. For that, it's a very easy one that we have learned earlier, this process. That is 6, 1 and 5. It's 5 into 8 raised to 0. This one would be 1 into 8 raised to 1. And this would be 6 into 8 raised to 2. We have to add all this. 8 raised to 0, that is 1 into 5 would give us 5 plus 8 raised to 1 into 1. So 8 plus 8 raised to 2, that is 64 into 6 would give us 384. Now we have to add all this and we would get 397 as base 10. So finally we have got this 397. Now the next conversion that we would be learning is binary to octal. For that, a clean area. Binary to octal. here we have a binary number that is 110 111 and 001. What we have to do to convert it into an octal? We have to take a group of 3 binary numbers. Actually, we are grouping them into 3. First these 3, then these 3, and then this 3. So you are making groups of 3 binary numbers. Okay. Now we will write these 3 groups a bit further away. That is 110, 111, and 001. Now we have to calculate the value of this binary number. So what it would be? For it, 1 into 2 raised to 0. For this 0 obviously. So 2 raised to 0 into 1 would give us 1. For this it would be 2 raised to 0, 2 raised to 1 and 2 raised to 2. So it would be 4 plus 2 plus 1. So it would be 7. And for this it would be obviously 0. This one would be 2 raised to 1 and this one would be 2 raised to 2. You must remember that we are actually multiplying this into 1, right? I'm not writing it here, but you have to assume that, or rather it's very implicit thing. Now 2 raised to 1 would give us 2 plus 2 raised to 2, that is 4, so it would be 6. Now our answer is 671. That is 671 as 8. This is our answer, and this is how we can obtain an octal number from a binary number. What we have to do is just group this into 3 binary numbers. Again, we will take another binary number. For that, I'll need some space. So delete. The another number that we will take is 0, 0, 1, 1, 0, 0, 1, 1, 1, 0. Here we have to group them into 3. So we will take 1, 1, 0 first, then 0, 0, 1, then 0, 0, 1, and this 0 is left alone. But it doesn't matter, because in a binary number, if you are having 0 on leftmost side, it won't change its value. So if we remove this 0 and this 0, it would not change its value. So we have 1, 1, 0, then 0, 0, 1, and again 0, 1, 1. Here again I am saying this 0 does not have its value. The value for this, that would be 2 raised to 0, but it's obviously 0, so it's 0. Or this 2 raised to 1, 2 raised to 2, so it would be 4 plus 2, so 6. Now for this it's only 1, so that would be 1. For this one, that is 2 raised to 0 plus 2 raised to 1. Here it will be 0, so no need to write 2 raised to 2. So 2 raised to 1, that is 2 plus 1, that is 3. So the binary number that is here is 316 in an octal form. So this is how we can get octal number from a binary number. Now you must be wondering why we are taking the group of 3. Why we are converting this whole binary number in 3 groups. In 3 number groups. Because there is a logical explanation behind this. For that, suppose we have a binary number like this. So its value would be 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 like this. So it would be 1, 2, 4 and 8. But as octal number has 8 as a base, and in the remember this, it has 0, 1 to 7 numbers. So an octal number carries maximum 7 values, actually 7 number. So here 4 plus 2 plus 1 makes 7. So that's why we are making a group of 3 numbers in binary. So that's why we are taking a group of 3. The next that we would be learning is octal to binary. For that, green. Octal to binary. And this we would convert this binary number, an octal number into a binary number. In previous conversion, we have learned how to convert a binary into an octal. We are just doing exactly opposite of it. Here, an octal number that we have here is 671. We have obtained that in previous conversion, remember? Now, we have to find a binary number for all these 3 digits. That would be 6, 7 and 1. For 1, just write it down like this, 4, 2, 1, because the first place in binary will have 1 as value as maximum, second place would have 2 as maximum value, and third place would have 4 as maximum value. For 1, it would be 0, 0, 1 as the last place have 1 value, right? For 7, 4 plus 2 plus 1 would make it 7. So we will write 1, 1, 1. And for 6, this 4 plus 2 would make it 6. So 1, 1, 0. So here we have our binary number. That is 1, 1, 0, 1, 1, 1 and 0, 0, 1. Base as 2. And this is our answer. And this is how an octal number can be converted into a binary number. Now, the next that we will be learning is decimal to hexadecimal. Decimal to hexadecimal. In this, we will convert a decimal number into a hexadecimal number. Hexadecimal has 16 as a base. So decimal number that we have here is 75. Again, that format. $75 would be written here, and we have to divide this 75 by 16 in this case, because hexadecimal has 16 as a base. So we would get 4 and 11 as remainder. Now 4 is not divisible by 16 as it's less than 16, so we will write 4 directly here. Now our answer is 411 from bottom to top, remember? But we cannot write 11 because in the set of hexadecimal that includes 0 to 9 and A to F. Remember? So for 11, our number that we would get is B. So our answer is 4B. Base as 16. Now, next we will convert an hexadecimal number into a decimal number. That is hexadecimal to decimal. Here we would convert this 4B into a decimal number. For that, clean space, that is The number that we have is 4b, base is 16. Here, for b, the number that is appropriate is 11. So, 4 and 11. Now, 11 into 16 raised to 0 and 4. That is 4 into 16 raised to 1. We have to add all this. Here, the 16 raised to 0 would give us 1, and into 11, that is 11 plus 16 raised to 1, that is 16 into 4 would give us 64, and the answer would be 75. Base as 10. So this is how decimal number can be obtained from an hexadecimal number. Now, the next conversion, that is binary to hexadecimal. For that, binary to hexadecimal. Here we have a binary number that is 0 0 1 1 1 1 0 1 1 1 0 0. In that octal number, we have taken a group of 3 numbers, but in this hexadecimal, we have to take a group of 4 numbers. So here it will be this 4, and this 4, this 4. We will write them a bit further away, that is 0 0 1 1 1 1 0 1 and 1 1 0 0. Now we will find the value of it. So here 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. Now 2 raised to 2, that is 4, plus 2 raised to 3, that is 8. Now 8 plus 4 would be 12. Here 2 raised to 0, here 0, 2 raised to 2 and 2 raised to 3. Here 1 plus 4 plus 8, so that would be 13. Now here, that is 2 raised to 0 and 2 raised to 1, so that would be 2 plus 1, so that would be 3. Now here we have 3, 13 and 12. So the answer that we would get is 3 D C, because in that set D is appropriate for 13 and C is given to 12. So this is the answer, 3DC as base 16. Now the next conversion would be from hexadecimal to a binary number. Here, in that we will take this 3DC number again. Hexadecimal to binary. Three D C base is 16. 3 for D, that is 13, that is appropriate, and for C, that is 12. Now we would find appropriate binary numbers for this. For again, for first place of binary, the maximum value would be 1. For second place, it would be 2. For third place, it would be 4. And for the fourth place, it would be 8. For here 12, 8 plus 4 would make 12. So we would write 1, 1, 0, 0. For 13, 8 plus 4 plus 1 would make it 13. So we would write 1, 1, 0, 1. And for 3, this 2 and 1 would make 3. So we would write 0, 0, 1, 1. And here we have our binary number. In binary number, this leftmost 0 would not make any difference to these numbers, but still we are writing that for understanding. The next conversion, that is from an hexadecimal number to an octal number, or an octal number to an hexadecimal number. For that, clean space, octal to hexadecimal. Now, here we have an octal number, that is 247 raised as 8. Now, what we have to do is we have to convert this number into a binary number. For that, this 7, it would be, again I'll write 1, 2 and 4 as, because in octal number there are only 3 spaces which are allowed. So for 7 it would be 1, 1, 1. For 4 it would be this only 4, so 1, 0, 0, and for 2 it will be, it's here, so 0, 1, 0, and here we have our number, that is 0, 1, 0, 1, 0, 0 and 1, 1, 1 is as binary 2. Now we have to convert this binary number into a hexadecimal number, and then we will get our hexadecimal number. For that, we have to group this into a group of 4 numbers, 4, 4 and 0, it doesn't matter anyway. For 1, 0, 1, 0, 0, 1, 1, 1. Now we have to find its value for that. That is 2 raised to 0, 2 raised to 1, 2 raised to 2 for this one. Now 2 raised to 0 would give us 1 plus 2 raised to 1, that is 2 plus 4. So 4 plus 2 is 6 plus 1, that is 7. Now here a 0, that doesn't matter. So for this one, 2 raised to 1. Again 0 doesn't matter. So 2 raised to 3. So it would be 8 plus 2 raised to 1, that is 2. That is 10. So we have 10 and 7. For 10, there is A in hexadecimal numbers. So we have the answer, that is A 7. So this is our answer. Now, the same process would be for hexadecimal number. Write down a hexadecimal number, then convert it into a binary, then group that into 3 numbers, and then convert it into an octal.